We are now looking at domain and range applications. So we've been talking about domain and range, and now we're going to apply it into real world situations. So the process here that it says, this process, we're going to be determining domain range in applied context. And it says, is the situation continuous or discrete? Remember we talked about that. Discrete has a break in it. Continuous keeps going. It includes all of those decimals, whole numbers, or infractions. So notice it says continuous domain and range is used in situations where parts of the variable make sense. So for example, if you have a decimal 15.25 hours in a week, you can work 15.25 hours in a week. So that is reasonable. So that would be continuous. A discrete example would be where whole number units are required. So for example, if we had 100.83 people, they would not attend a fundraiser. You can't have 0.83 of a person. So integers should be used in this case, so that would be a discrete example. It says, is the situation limited by its real-world constraints? For example, many values will only be positive in real-world situations. Okay, or the problem is only interested in outcomes over a specific period. So there will be some real-world constraints. And then it says if the domain is restricted, do the output values of the range correspond to the domain restrictions? So you're going to be using a function rule, an equation, graph, or table to check the reasonableness of your domain and range. All right, so let's look at our first example here. So it says Sophia works as a lifeguard at her local pool during the summer, earning $12 per hour. The pool is open 5 days per week, 6 hours per day. Analyze Sophia's potential earnings for 10 weeks. The pool is open each summer. We're going to write a function rule to model the situation. So function notation, we have f of x equals. So we are looking for a function rule to determine her potential earnings. So she's making $12 for every hour that she works. So we'll use an x there, and so that will be our function rule. It says to identify the independent variable. Remember, independent is x. So the x in this case on our function rule represents the number of hours. So time. And then the dependent, remember we said dependent was y. So if we look at the y, which is function notation f of x, that would give us the total amount that she's earning. So that would be her earnings in dollars. Okay, so it says, is the situation continuous or discrete? This would be continuous here. It says to explain why. Because she is allowed to work part of an hour. So she can work 3.5 hours. She can work 4.5 hours. She can work an hour and 15 minutes. So this would be continuous. We can use those decimals, fractions in between each whole number. So are there any restrictions on the independent variable? So independent is your x, which was the number of hours. Clearly, we want that min value to be 0. So if she doesn't work, she hasn't worked any, so that would be 0. So we can't have any negative number of hours that she worked. And then the max, we do have a max because they're only open 10 weeks. So I would need to do 5 times 6, because 5 days per week, 6 hours per day, and then also times it by the 10 weeks that they're open. So that would give me a total of 300. So the max would be 300 possible hours. I'll label it as hours. Okay, so it says, are there any restrictions on the dependent variable, which is your y, so earnings? So the minimum she can make is $0. And then the max, so say she works 300 hours, which means she works every single day and then every single hour that they're open. So 300 we found, and she's earning $12 per hour. So if we did 300 times 12, that would give us $3,600. So the max amount she can make is $3,600. Okay, so you're having to think about the situation and then figure out your restrictions. Okay, so we want to write the domain and range of the situation in inequality notation, set notation, and interval notation. So inequality notation on this, we are going from 0 to 300 on the domain. This is your domain. It does include 0 and 300. The range for that, now we're looking for the y. So here's our y here. So the range for that, we are going from 0 to 3600. So there's our inequality notation for both of those. And now we're going to use set notation. So remember the curly bracket, x, the set of all x's, is an element of all real numbers, because remember we are including those decimals, and then we just write that inequality. Set for range, y is an element of all real numbers, and then just bringing down that inequality. Okay, so the interval notation, we're starting with the smallest. Our min was 0. We're going to the largest, max, which was 300. It does include both, so remember we do need brackets. The range, we're going from 0 to 3600. Again, it does include both of them, so we'll put brackets around it. So now we are doing the same thing that we've been doing, except now we're looking at real world situations. So let's take a look at the back. Okay, so number 2, the band booster ordered 200 playoff shirts to sell at Friday's football game. The shirts cost $1,200 to print, and they are being sold for $15 each. Analyze the booster club's potential profit from their t-shirt sales. So if you don't know what profit is how much you're making from selling a product. So when you're finding profit, you're having to take your total sales and then take away how much it costs to make. So you might write that down. So profit, total sales, minus your amount to produce the product that you're selling. So to write our function, so we're going to start out with function notation. We're going to take our total sales, so they're selling them for $15 each, so 15 times x. And then we're going to take away how much it's actually costing to make the shirts. It says $1,200 to print, so $1,200. We don't need to multiply by x, that's just the fee that they're charged. We're going to identify the independent variable, which is x. So x on this function here represents the number of shirts sold. And then the dependent variable, which is your y, was your profit in dollars. What is the maximum value of the domain? Explain how you arrived at your answer. Minimum. So the minimum value of your domain was the number of shirts sold would be 0, because we always want it to be positive. So number of shirts has to be positive. And then it says, what is your minimum value of the range? So profit. So if we sold 0 shirts, we would be losing $1,200, because that's how much it costs to print them. So negative $1,200. So we will have a negative on the range here, because that is the initial cost to print the shirts. Okay, so then looking at our maximum value of the x, so remember they are ordering 200 shirts, so the max would be 200. because they ordered 200 shirts. And then we want to look at the maximum value of the range. So if they were to sell 200, all 200 shirts, they're selling them at $15 each. So if we were to work that out, we also need to take away that 1,200. So I'm looking at this here. That would give us 1,800. So the max would be 1,800 for your profit. And then this explains here how we arrived at our answer. All right, so then the next part it says, is the situation continuous or discrete? So we're talking about the number of shirts sold. We can't sell a portion of one shirt. So this is a discrete situation. Oh, my bad. So I'm just going to put, it is only reasonable to sell whole shirts. So we can't sell a portion of one shirt. It says state the domain of the function using a verbal description. So domain is X. So the domain includes all integers, because we're not using any of those decimals or fractions, between 0 and 200, because that was the max number that they ordered. Okay, so let's look at this last example. So example 3, Eva stacks boxes of lawn chairs on top of a pallet to prepare them for freight shipping. The pallet is 6.5 inches tall. The boxes are 8 inches tall and have a base about the same size as the pallet. The maximum allowed height is 64 inches. The equation H equals 6.5 plus 8b represents the total height H, and then B is your number of boxes in the stack. Determine whether the situation is continuous or discrete, and then state the domain of this situation. So first off, B represents your number of boxes. We can't have a portion of a box. It's either 1, 2, 3, 4, and so on. So this is going to be a discrete situation. And then we need to figure out our domain. So we know H, which is your Y there, is your height of the bundle. Remember, it told us the maximum height was 64. So I'm going to plug that in here to figure out what our B would have to be, which is the number of boxes allowed for that maximum height. So I would solve for B, so I would subtract 6.5, and then I would divide by the 8, so that's going to be 57.5, and then divide by 8, and that gives you 7.19, which again, we can't have a portion of a box. So that means the maximum number of boxes that we can stack are 7. So my domain, we're going to have to list it out. It's discrete. So I'm going to use my curly bracket 0 because we don't have to stack any. 0, 1. We're going to go all the way up to 7. We can't go 8 because 7.19 gives us that maximum height. So that would be our domain. So this is domain and range applications. Let me know if you have any questions.